Okay, today we move to the last part of the Z test. So this part will be the last part that we're going to use the Z to do the hypothesis test. Okay, and this part we will talk about the Poisson distributions. So in order to, I also remember that before, if we have a large number for Poisson, okay, and we need to find the probability, okay, so how are we going to find? Because we divide Poisson in this way, okay, and the n can be 0 and can be until infinity, right? So if you have the n number that the things that they want you to find, let's say from p larger than 100, and the question did not give you a finite stopping point, so how are you going to find the answer, right? and in Poisson is similar to the binomial. If you have need to find a large number, okay, and that involve a multi-stage many step, right? Normally about more than 10 step, you need to consider to use the normal approximation to do this question, right? So for Poisson, I also remember what is the criteria to do the normal approximation, right? So you need to fulfill some criteria in order to do the normal approximation. So for Poisson, right, refresh a bit, and what is the criteria? The criteria will be lambda must be larger than 15. Okay, so for Poisson only one parameter, so you need to test the mean. You need to determine the mean is larger than 15. If mean is larger than 15, right, the average, okay, you can safe to use the normal approximation. Okay, this one is from the chapter 1. Okay, so once you apply the normal approximation, you will get x lambda and lambda, like some refresh and revision on that. And as you know that uh, so if you want to do the z value, you will have a x minus this x is the value that given in the question, and this lambda is the benchmark that you need to compare, and same things divided by the square root of lambda, the standard deviation, right? So for this question, don't forget this x, you also need to do the continuity correction, okay? So you need to do the continuity correction for this part, okay? So once you have this, then you can compare the z value, okay, to the percentage of significant level, so that or you can use a similar way by using the z test in order to determine the final hypothesis, okay? So this is the way to use a normal approximation and z test to test the hypothesis in the discrete variables. Okay, so now we proceed to question 13. Okay, question 13. Okay, question 13. The number of hits per day x on a property website can be modeled by a Poisson distribution with a mean 75 on a randomly chosen day following a advertising campaign that were 89 hits. Okay, this is the result that you get. Test at 3% significant level whether the mean number of hits per day has increased, right? So this question given mentioned already, this is a Poisson distribution, right? Okay, uh, mean by mean 75. Okay, so in order to start the hypothesis test, you may state your parameter first. Okay, so the parameter for this case is a Poisson. Okay, and if you have parameter, you can set your hypothesis. Okay, the first one, lambda equal to 75. This one is always is a benchmark, always equal. Okay, so the second one, what they want to test, whether the number of hits per day has increased. So increase means you need to test the upper side, larger, increase. Okay, so this is the things that you need to test. Right, and the question they get is the, the output that you get is 89. Actually, what you need to find at the beginning actually is this 89. You're going to test the upper side, but larger than 89, either you from 89 to infinity. Okay, so for Poisson, you will 1 minus px smaller than 89 in order to find the probability. But if you calculate, you may need have a 90 step, maybe from 0 to 89, or 0, okay, about 90 step in order to calculate. So it's not possible for you to do that in the exam, 90 step. Okay, so in this situation, you need to check again. Okay, if lambda is equal to 75 in this case, so larger than 15, so that from these two criteria, you know that you need to apply approximation to find the in order to do the test. Okay, so for this question, what should you do? Once you have this, you can form the distribution by using the approximation 75 and 75. Okay, so once you have this, okay, you can find the z value already. So the z value will be equal to x minus 75 over square root of 75. Right, just now don't forget what you need to find is px larger or equal to 89. So means your z after you doing the continuity correction will be 88.5 minus 85 over square root of 75. Okay, so you will have z equal to 1.558. Okay, so when z equal to 1.58, you need to compare the significant level. Significant level is 3%, so what you need to find is the upper part of 0.97. 0.97 is 0.97 probability. You cannot find from the critical value table. Okay, so you need to find from the table, the measure table, the main table. The measure table give you 1.882. Okay, 1.88, sorry, 1.882. Okay, 1.882. So you will have smaller than 1.882. Okay, so in this situation, you know that this is not in the critical region. So if it not in the critical region means reject H1 in favor of H naught, right? So reject H1 in favor of H naught. So once you have this, you can state your final conclusion. Your final conclusion will be, you can say at 3% significant level. Okay. That the mean number of hits per day has increased. Okay, has increased following the advertisement or say advertising campaign is not supported, right? Okay, so depends on you. This is a conclusion that I written, but if you have a similar conclusion is okay, but must be according to the context, right? So this is for question 13. Now we move to question 14. Okay, question 14. Okay, for question 14, a flight stick to the web pane at a random point. The average number of flights is 2 per square meter. A wall with an area 22 meter square is painted with a new type of paint, which the manufacturer claims is flight repellent. It is found that 27 flights stick to this wall. Use a suitable approximation to test the manufacturer claims at 1% significant level. Take the null hypothesis to be mu equals to 44, where mu is a population mean. Okay. So for this question, the question already told you okay, the average number is 2 per meter square. Okay, so now you have 22 meter square. You can this one the keywords is average. So once you do have the average, the question asks you to do the approximation. So you can set your parameter first, Poisson. Okay, so 2 per meter square. Now you have 22, so you have 44, right, per 22 meter square. This is your parameter, and your hypothesis will be question given mu equal to 44. Okay, test the material claims. The material claim is the flight repellent. So if this is a repellent, means the flight should be lesser, right? Lesser only, lesser. Okay, so this is the hypothesis that you need to form. Once you form, then you can start to do the approximation. Okay. So once you form, you may form the new parameter that you have, 44 and 44. Okay, and what you need to find is px smaller equal to 27, right? Because repellent lower side. So from this you need to find the z value. Okay, so you have a 27.5 minus 44. Okay, over square root of 44. Okay, so you can calculate the value. This value will be equal to negative 2.487. Okay, so once you have this, you can compare to the z value. This question 1% significant level and the lower tail, so you look for 0.99. 0.99 mean you have 2.3. So this value is less than negative 2.326, less than negative 2.326. So is it in the critical region? Yes, in the critical region. So if in the critical region means reject H naught, okay, in favor of H1. Okay, So you can say that at 1% significant level, the mean number of flights has decreased is supported. You can say like that. Okay, so reject H node in favor of H1 at 1% significant level, the mean number of flights has decreased is supported. Okay, so this is for question 14. Question 14. Right, now we move to the last question, question 15. Okay, for question 15, the number of cases X of a particular disease treated each year at the hospital follows a Poisson distribution with a mean 56. Following a campaign to alert people to preventive measures, it is believed that the mean number of cases treated in a year will decrease. A hypothesis test to be carried out to test the node hypothesis lambda equals to 56 against the alternative hypothesis lambda smaller than 56. It is decided to reject the node hypothesis if x smaller equal to 40. Okay. So find the probability of making type 1 error. Okay, part 1. Part 2, find the probability that making type 2 error if lambda equals to 45. So we start from the part 1 first. And if you want to run the test, state the hypothesis. 56. Lambda smaller than 56. This one given, these two. And your parameter will be 56. This is a parameter. Okay. And so the question is asked you to find the probability of type 1 error. So I clear this one first. So the probability of type 1 error will be equal to the probability of you reject H naught. Right. So these are the things that you need to remember. When you will reject H naught, will be the probability of x smaller equal to 40. This one given in the question. Right. So if x smaller equal to 40, you need to calculate. You need at least 0 to 40. Right. You have 41 steps. Okay. So this situation, you will need to do the approximation. Okay. Even the question never mentioned. So once you want to do the approximation, you need to state the new parameter. Okay, so now you can do the hypothesis, the Z. So smaller equal to 40 means 40.5 minus 56 over square root of 56. So equal to PZ smaller than negative 2.071. Okay, so once you have this, will be equal to 1 minus PZ smaller than 2.071. Okay, so 2.01, if you look at the table, 2.0 2.071. Okay, 0.9808. So once you minus this, okay, minus this, you will have 0.0 192. Okay, so this is the probability of type 1 error. Probability of type 1 error. Okay, So this is things for part 1. Part 2. Part 2, they ask you to find the probability of making a type 2 error if lambda equal to 45. Okay, the probability of type 2 error if lambda equal to 45. Okay, so now you need to change your parameter again. So you check your parameter is n 45 45. Okay, you can see these two, the lambda still more than 15. So you can use the normal approximation for this question. Alright, so same things, the probability of type 2 error will be equal to the probability of u except h naught, right? Okay, so I said this is very important. Okay, so you just remember the front part, right? So probability of type 2 error is equal to the probability of you accept h naught. Okay, so once you have this, then you can proceed to calculate do the approximation. Okay, so when you accept h naught, what happened? Px larger than 40. Okay, larger than 40 means is equal to pz larger than 40.5 minus 45 over square root of 45. Okay, so this is equal to pz larger than negative 0.671, right? And once you have this, you can proceed to calculate. So this is equal to pz smaller than 0.671. Okay, so if you look at the table, and so the values will be at 0.671, so 7489. Okay, so you may simplify, your answer becomes 749, right? So this is the last question for Poisson. Okay, that you need to do the approximation. Okay, so tomorrow we will move to the last chapters. The last chapter will be the discrete test. Okay, so your discrete test only two. One is binomial and one is Poisson. So the discrete test, the structure is similar to Z test. Okay, but when you do the discrete test means you are able to do that without doing the approximation. Okay, so means the numbers should be smaller. Okay, what you need to do. Okay, so the discrete test you will not involve z value, you won't, but you need to calculate the probability in different way. Okay, so for today I will post one question for you to do that. And remember that I did not give you any additional exercise, but please use your time, proceed to the past year booklet, try as much as you can, because the Z test we already done. You only remain one chapter discrete test that you cannot do. You should able to clear all chapters. Okay, for chapter 1 Poisson, linear combination, estimation, sampling, okay, linear combination, something like that, and continuous random variables. All these you can clear. Okay, just remain one chapter discrete test. Okay, okay, we will do it tomorrow. I think for tomorrow or one more week we can clear all the syllabus. Okay, so then we start the revision by combined questions. Okay, so thank you, see you tomorrow.